Hi Math 9s, welcome to another Math 9 video. Today we're doing the last section from chapter 1, which is on power rules. So I'm just going to run through a few examples. It'll be a short one because this is review from what you did last year. So we're going to start off first with something that's called the power rule. And that looks something like this. If we have x to the power of m, and the whole thing is to the power of n, then we can simply take the exponents and just multiply them together. So it would be x to the mn. So I'm going to put this in a box because this is an important one, and this is something that you will have to know or memorize. That will help to make things a little bit easier for you. So to take a look at an example of what this would look like in action, if we had something like 5 to the power of 3, and then the whole thing was to the power of 2, what this would end up being is when we multiply it together, it would end up giving us an answer of 5 to the power of 6. Now I've mentioned this in class before. If you have something like 5 to the power of 6, without a calculator, that's going to be pretty difficult and time-consuming to figure out the exact answer. So you could just leave your answer in this form. 5 to the power of 6 would be perfectly fine for you to leave it that way. And then, as always, let's make it a little more exciting. Let's say we have a to the power of b, and the whole thing is to the power of 2a. Then when we go to simplify this, remember that the base always stays the same. So the base in the answer is going to be a, and we just simply multiply the other two values together. So in this case, we're dealing with a b multiplied by a 2a. So the number always goes first, and then we put the variables in alphabetical order. 2ab is the way that I would give my simplified answer to this. Okay, so then I feel like you probably are okay with understanding that rule and the application of it. So let's take a look at something that's a little bit different. If we have something like x over y, all to the power of n, I want you to know that that is the same thing as saying x to the n over y to the n. And again, this is an important rule. I'm going to put it in a big, huge box here and put a little star beside it so that you know. But basically what this means is we took the exponent and we distributed it here, top and bottom. And that's the general rule of what you are supposed to do with this. So again, let's take a look, as always, at an example of what this would look like. So if we had something like 4 over 5, and the whole thing is to the power of 2, then what that means is when we go to find the solution of this, I would apply that to top and bottom. So it would be like saying 4 squared over 5 squared. And I am finding many of you are trying to skip steps and just move ahead to the solution, but I really want you to get into the habit of slowing things down. We're not in any rush to solve this and to get the answer. I really want you to understand the process. So do make sure that you take a second to write this out, and that'll eliminate the little mistakes that I'm seeing many of you making. So 4 squared we know is just 4 times 4, which is 16. And 5 squared would be 5 times 5, which is 25. And that's how we would give our solution in the end. Okay, let's take a look at another one that's slightly different with a little bit more going on. If I have x squared, that's over y to the 5, and the whole thing is to the power of 3. And I want to know what this is going to be equal to. Let's focus just on that one, so I'll zoom into that. Okay, so then again, we know that we have to distribute that 3 top and bottom, but there already are exponents there. So we know that this is sort of combining the two rules we did today. So basically my no and my answer, I'm going to have a fraction. And remember what I taught you? I taught you to live in denial or to break things down into simple steps. So if we just zoom in at the top, then we would have x to the power of 3 times 2, which is 6. And now if we move to the bottom, the base stays the same, so it's going to be y. And then we have a 5 times 3, so it's going to be to the power of 15. So after all that, this would be my simplified solution. Okay, so then if we have something with a little bit more going on, let's say, for example, we have negative 2 to the power of 2 over negative 2 to the power of 3, and then the whole thing is to the power of 4. Oh, it's kind of ugly and messy looking. Let me try to fix that and make it look better. So if this is the question that we have, there's a lot of stuff going on there. We do have some choices or options for what we do with this. You could just deal with the inside first. Notice that the top and the bottom both have the same base. And according to bed mass, we could simplify in there first and then deal with the 4 on the outside. Or you could distribute that 4 to the top and the bottom and then deal with the subtracting afterwards. So it's your choice. But what I like to always do is simplify things as much as possible. So I think simplifying means if you can shrink something down first before you deal with the exponent, then that's probably going to make life easier for us. So let's do that. Let's say this. I know that I have to the power of 4 on the outside, and I know that I can rewrite my base using the same number, so negative 2 is the base, and then I would do 2 minus 3. So I know that 2 minus 3 gives me negative 1. So I want you to take a look at that and make sure that you're clear on where we got this. So if I look at it, the base or the number at the top and the bottom is the same. That's how I know I can use my exponent laws. And then I just took the 2 at the top and I subtracted 3 from it, and that's how I got this negative 1. And the other stuff to the power of 4 was already there. I had already written it out. And then I'm going to rewrite the base again. I know I'm going to have negative 2 in my answer. And then I multiply these two. Negative 1 times 4 gives me negative 4. So that is the same thing as writing 1 over negative 2 to the power of 4. And I'll just remind you of this. We never want a negative exponent. So if we have a negative exponent there, we want to take the reciprocal of the base, which would be 1 over negative 2, and then that makes the exponent positive. And in this case, we can actually simplify this because negative 2, well, let me mention this. If you have a negative on the inside of the brackets and your exponent here is even, I know in my answer I'm going to get a positive number at the bottom. So it's like I could ignore that negative or say that it's not there. And then 2 to the power of 4 would be 2 times 2 is 4, times 2 is 8, times 2 is 16. So my answer after all of that is simply 1 over 16. Okay, so the questions that I want you to work on are numbers 3, 4, and 6. I want you to do the odd letters, so a reminder that that means like A, C, E, G, etc., etc. So you're skipping letters. And then for numbers 8 and 10, you're going to only do A, C, and E. So you're not even going to move past that. So that should give you good practice on this, and I hope you found this